Lesson 9.2a, finding the roots and the vertex. Our essential question is, how can I identify the roots, vertex, and y-intercepts given quadratic equations written in various forms, and how can I find the vertex of a parabola from knowing its x-intercepts? What is a root and where are they located? A root is the same thing as an x-intercept, which is where it crosses the x-axis. So remember, your x-axis is right here, and so wherever this parabola is crossing the x-axis are your roots. So those are the two roots, and it looks like the points that they're located at are -7, 0, and 3, 0. What is a y-intercept and where is it located? A y-intercept is where it crosses the y-axis. So now we're looking at this vertical axis here, and we're seeing where our parabola is crossing. It doesn't look like it's crossing at a very even point where we could state the point, but we do know that whenever we cross the y-axis, our x value is 0, and then our y value would be something. So I'm going to put a little question mark there for our y value. Okay, but notice in y-intercepts, our x value is 0, and for your roots or for your x-intercepts above, your y value is 0. What is a vertex and where is it located? The vertex is always the maximum or minimum point, depending on what direction your parabola is going. So it's down here. It's kind of the tip of that U. Again, we don't really know what that point is, but we do know we can see that it is at the x value being -2, but we don't know what the y value is. And what is the line of symmetry? The line of symmetry is this invisible line that would kind of cut that parabola in half. And so the equation of the line is always that x equals your h value. And remember, the h value is the x value of your vertex. So really our equation would be that x equals -2. Given the graph, find each of the following. A, find the vertex. So the vertex would be right here, and that looks like it's at -1, -9. Part B, write the equation in vertex form. The vertex form is written over at the left, and so remember your h and your k value are your vertex, and so our vertex, it goes in order. H is there, k is your y value, and so if you plug those into the equation, we have x, it's -1 or just +1 squared, and then it's plus k, so that'd be a -9. To find our a value, we look over at the graph and we look at our vertex that's already plotted, and then we look to the right or to the left one space and see what your y value is or how far away vertically that is from your vertex. And so if we trace it up, it hits in this place right here, and that's just 1 away vertically. So our a value is 1. Our y-intercept is where our parabola crosses the y-axis, which is at that blue dot I just made. And so our x value is 0, but our y value looks like it's down at -8. And our roots are where it crosses your x-axis. So it looks like we have one at -4, 0, and the other one over at 2, 0. So we've looked at our general form and we've looked at our vertex form of a quadratic. And so now we're going to look at factored form. Factored form is that y equals a times x minus r1 times x minus r2. R1 and R2 are both your roots, and so I'm going to say these are your roots, or they're the same thing as your x-intercepts. And the same goes for R2. Okay, a parabola should always cross your x-axis twice. And then your a value is your stretch or shrink factor. So if it looks like it's being stretched up, it's getting taller, or if it looks like it's getting pushed down and shrunk down, then that a value would be different. If it's just a normal parabola, then your a value is always just 1. Example B, find the roots of each equation below. In our factored form, in the parentheses, we have both of our roots as r1 and r2. So if we compare this equation to example A, which is y equals x minus 3 times x plus 9, we can find the roots pretty easily by just matching the numbers up with the r1 and r2. So in the first parentheses, it's usually x minus r1, and in our problem, we now have x minus 3. So that tells us that r1 is the same as 3. So we can go ahead and say that one of our roots is at 3, 0. The same goes with our second root. So usually r2 is in the parentheses, and this time we have a plus 9. So notice though that it usually is x minus r2, and now we have an x plus 9. So that means our sign changed. So it's not just a positive 9, we want to change that to a -9, 0. So if you can kind of start remembering that really whatever is inside these parentheses, the sign is going to change in your root. So if it's minus 3, it now became plus a positive 3. When it was a positive 9, it became a negative 9. And this is because really when we're finding a root, that's when our y value is 0. So really all we're doing is taking each set of parentheses and we're setting it equal to 0, since our y would be 0. And so if you were to solve this by adding the 3 to both sides, then you would have found that x would equal positive 3. So it changes the sign. Part B, same thing. We look in our parentheses, change the sign for your roots. So since it is x minus 8, our root would be a positive 8, 0, and a positive 5, 0. Part C is written a little differently. We have x times x plus 2. We still have 2 as a root, which would make that a negative 2, 0. And then with that x, if we wanted to rewrite that in parentheses, we needed to have x minus something or x plus something to get to just be an x. And so in order to cancel out any numbers on the other side of that minus, we would have to only be subtracting a 0. X minus 0 is the same as x. So I'm going to rewrite that as x minus 0 and just get rid of that x. And so now we can tell that one of our roots is at 0, 0. On parts D, E, and F, we have one factor that has not just an x at the beginning, there's a number in front of the x. And so if you ever have that, we can't just choose this negative 4 as our root, we actually have to solve it. So I'm going to go ahead and write this 2x minus 4, just rewrite it over here, and we're making our y value be 0 to make it a root. So we set it equal to 0, and then we can solve. Adding 4 to both sides, we have 2x equals 4, and dividing by 2, we get our x value to equal 2. So one of our roots is at 2, 0, and the other root, this other set of parentheses, is just a normal x plus 3, which would make that a negative 3, 0. Parts E and F are both very similar to part D, so I recommend pausing this video and trying those two on your own. Once you solve that first one by setting it equal to 0, you should get negative 2, 0, and then 8, 0. And part F, you should have 3, 0, and negative 4/5, 0. Given the roots, write the equation in factored form using any a value you want. Part A, 3, 0, and negative 2, 0. So we're given our two roots, we're given R1 and R2, and so we just need to plug those into that equation. And so it's x minus R1, so it should be x minus 3, and then it'd be minus negative 2, or just know you change the sign to a positive 2. And you can choose any a value you want to go here. So I'm just going to go ahead and choose 1. You can choose any number you want. Example B, we have negative 7 as R1 and negative 0.5 as R2. So you should have x plus 7 times x plus 0.5, and you can choose any a value you want. Part D, find the vertex of each of the following. Part A is already in vertex form, so remember we always have h and k in our vertex form, which is our vertex. So we'd have the 0.52. Same thing with part B, but there's really nothing being added out here, so we can make that a plus 0, which now would tell us our vertex is at negative 3, 0. Part C is our parent function, which we know goes through the origin at 0, 0. Part D, I'm going to rewrite this in vertex form. So we know that 0.5 is our a value. And so if we have x squared, we know really we took x minus nothing and squared it. That would simplify back down to being x squared. And then that minus 8 is on the outside. So now we can see we have an h and a k, and so our vertex would be at 0, 8. Example E, the roots of the function is where the function equals 0. The vertex is exactly halfway between the roots. 1. Circle the roots on the graph and list them for this function. There are two roots. The points are negative 3, 0, and 2, 0. Step 2. Calculate the vertex of this graph using the roots and the equation. We know that the vertex is exactly halfway between the roots. So to find the x value of the vertex, we want to find the halfway point between negative 3 and 2 by adding those 2 points together and dividing it by 2. So the halfway point would just be dividing by 2. So that would tell us that the x value of our vertex is negative 1/2. To find our y value, we're going to go back into our equation that we were given, and we're going to substitute negative 1/2 anywhere we see an x. And once you calculate all that out, you should get y equals negative 6.25. And so that would be our vertex.